For our first application this week, we have yet another automotive application. And this one is specifically automotive, yes, but it really goes into any manufacturing environment. There are many reasons why you'd want to do this same exact workflow. So with this, we have an application where we've scanned a factory floor. So you could see how this would not necessarily have to be automotive. It could be any manufacturing environment. It just happens to be automotive, in which there needs to be some manufacturing line planning and documentation of old lines and build outs of new lines. And that's where this application is really neat. On the practical side, I'll go in and roll back and just show how we accomplish this workflow. But I will say a lot of the application really hinges on the fact that you can scan and archive an entire factory floor and use that data as an archive for later purposes, whether it's going back and looking at the facility itself, looking at what the line used to be and what it is now, and you can use the scanning as a documentation to record history and kind of go back and forth and toggle, even overlay the scans on top of each other. But today we're going to roll back through the history and talk about how it was reverse engineered, this longer range data itself. So we'll go ahead and jump right in. So here I have the final model, just kind of rotating around and zooming in, and you can see how we can extract this could either be a current line or a prospective line, or there's lots of different applications for this, but I figured I would walk through, how this was modeled is pretty basic, although I will say I'll show a couple things that are particular to modeling something on this size or scale that might be relevant to how this project would go and how you could speed it up a little faster. So there is the CAD model. Here is the scan data. So immediately you're looking at this, I'm reading your mind here, right? You're looking at it going, oh, where's the rest? Look at this. There's missing areas here. Well, with long range scanning, you can spend an awful lot of time putting a scanner on a tripod here, 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 all the way around an object. And if all you're trying to do is locate where this box is in space, or where this ladder is in space, and if this is a known thing, where that ladder is, if you know that that's the 24-inch spec ladder or whatever, then you have a general idea of what it is. You just need to know its location corresponding to the surrounding facility, right? So the idea here is you can burn many, many hours scanning and trying to envelop a whole area. So with the long range scan market, you will notice that there's lots of scanning of just the general area itself and not filling in every single, like they could have come in here and put the scanner around each one of these and scanned it. But the general idea is we know it's the same model robot. So then we can just model one of them and go from there. So that's just the general idea of with long range scanner, you're going to see sparse data available and that we can still model what we need from it and go from there. So let's go ahead and roll back, and we'll just go here and just kind of go right from the beginning and just kind of take a look at what this person did when they modeled this project. So we'll go ahead and we went a little further back. Let's go forward one step now. They modeled the floor. So we went ahead and we created a sketch that modeled the floor. Awesome. So nice. But that's where we start, at the ground floor there. Now we bump forward here, and it looks like we went ahead and extruded each one of those individual beams there. And let's just edit that sketch just to see how they went about doing it. So we'll just turn the solids and scans off, polygons, And you see here that they just came in. And you'll see with long range data, this is a shift in thinking here. Where if I turn on the polygon mesh, look at there's lots going on. And the idea is I know that this is 50 by 70 millimeter box tubing. I'm going to model it in this position in order to extract and simplify it and use it for design purposes here. So just a little bit of a shift in thinking as to how you would go about modeling this is they went ahead and modeled those right there. And then we'll just bump forward here a couple more. And it looks like they did the rest of those here. Now, one thing that I want to point out again is often I've joked around in some of these training classes saying that I am a 3D connection salesperson because you'll notice that I am using the Space Mouse, the Space Pilot Pro, the old faithful that I've had forever. And the reason why I bring that up is it really speeds up this stuff right here. So I've set shortcuts on my Space Pilot Pro, and this can just help you in your productivity using our software and utilizing it. For rotating and translating, my sales pitch is this. It makes it the same. So I can rotate and translate, on view here in 3D the same way that I do inside of SolidWorks, inside of Inventor, inside of whatever, as long as you get that 3D mouse connected. And then now that it was years ago that we connected the ability to use the driver to add shortcuts. So I went through the 3D connection software and I added the show meshes, show solids, hide and show, and that's what I'm using, and I've been using it since the beginning of this webinar, just so you know that that's what's going on. And for long range data, this helps a lot. And it also helps a lot just for general reverse engineering because you're always turning on and off the mesh, on and off the solid, on and off the surfaces. I have it set for surfaces as well and regions, so you can turn on the regions. So if I turn that off, and there aren't any regions at the moment, as you can see. And then I'm also a big proponent of their regular CAD mouse as well. I use that. I'm also using that in conjunction with this. So that is the end of my little sales pitch, but I just wanted to let you guys know that that's how I utilize these. So go ahead and roll forward a little more, and you see here that they're adding the cross members in here. And if we just edit those sketches, you'll see that it looks like they're using over there. They're modeling those right there. So we'll just turn that back on, get out of that sketch. And let's go forward a few steps. Oh, I didn't want to go to the end. Accidentally clicked end, but we will roll back to this extrude merge 6 here in a second there. So roll back. So now we're back to where we were. So if I just click on here, looks like we move forward a little bit. We did these cross members on this side. And we'll roll forward a few steps here. Lots of extrudes. Okay, so now we went ahead and we're extruding this. We'll just rotate around here. Hide the mesh there. Hide the solid. You'll see that there are these. It looks like these are the ductwork for the wires that go to the robot. So you're modeling where those are. The ductwork that delivers all of the cables and everything, pipes, everything that goes to it from the controllers now. And then now it looks like we're adding some of the other ductwork on the other side. I'll rotate it here in a second. It just takes it a second to update. So you see that if we click on this, it'll kind of highlight the different things that we are working with. So turn that mesh off so you can see it. So cutting away There's a stand that they modeled, and then this ductwork here on this side. So you can see here a lot more just constructive modeling going on throughout this practice. So it's very valuable, you see here, just to be able to lay out. Obviously, with this type of reverse engineering project, it's really just important to know the scope. What facilities, what armatures, which structures are you interested in? Only model those things, because you could literally spend many hours just modeling this entire thing, just modeling every nut and bolt in this facility here, and you'll see it all really depends on what the scope of the project is, how much you need to model, and then if there are duplicate things, you can use the patterning tools. So for some of this stuff, it's you model one side, you could have mirrored it across by just using a plane and all those different things, or mirror the sketch too. There's lots of different ways you could go about doing it. So you see here that they added a bunch. It looks like there is a big focus on this. So the robot is going to interface with a fixture here, it appears to me. So it's important for these robots to know where all of this fixturing is, for reference. You see there's multiple robots, it looks like, interacting with these fixtures. That's kind of what I'm noticing now. And again, this isn't my project. I'm just rolling forward, looking at it, inferring what's going on here. But it seems like that's really important. They need the relationships between all of the protective facility around the outside, and then where the fixtures are, and then the specific fixture. This might be for a specific line, right? And they just need to know where that is in space in relation to the robot and in relation to all the individual pieces there. So again, turn that off, highlight this. It looks like, yeah, the feet, all that stuff is going on. So, and I'll jump forward a bigger step here in this next section here. So now let's go ahead and roll forward here. Let's take a good chunk forward. On the surface, it doesn't look like much, but all of this stuff was modeled. This controller, as I highlight these, you can see all of that stuff was modeled. Just locating where all of that stuff is. And again, just taking steps forward. All of this stuff started to populate. It seems like there's more safety sections that they've added. They've modeled where all the safety clearance fabrication is, and we'll just keep stepping forward there. Now we got a lot more facility stuff going. So I will click on some things here. Okay, just that the conduit coming down to the controller, some more conduit coming from the roof. Like, and if it was part of the scope here, like you could model this where it connects to the facility. I've seen that stuff all modeled before. There is the ladder and all that structure of where that all goes. So we'll just take some more steps forward, and we'll see if we get into the robot. Okay, so it looks like now they've progressed into modeling the robot now. So we're modeling just the generic shapes of the robot. Now, I happen to know that, they modeled this in this instance because maybe this was years ago, but I happen to know that most of these robots come with 3D models now for all of the different aftermarket reasons why you would want to simulate. All the manufacturers should be giving you some access, so you might not even have to model a lot of this in this instance here, because these robots now have models available that you can use. So you would be able to come over and import a CAD object in here, and then use, if I come over to the model section, you could use transform body and move that CAD body of the assembly for a robot into a position and use the scan data to help you locate a CAD model and put it in a spot, right? And then that would then be used. You could then use transform body to select a CAD body and even duplicate it and copy it over here and do the same thing. So import a CAD body from another source, because now I know that these are available. A lot of them are to use, because these companies want you to spec in their robots in your designs. So they will give you at least the external information about it, not necessarily every nut and bolt or whatever, but some for clearances and for simulation. So now they're going to go ahead and model the other one. And really they're spending time just modeling this for simulation purposes, not because they're modeling every nut and bolt here. They need to know where this robot is, where its home position is, right? And all the clearances around it and where it is in relation to the fixture. So that's what's going on here. Again, they didn't take if we turn on the mesh again, it didn't take the approach where we're going to model every little thing here. So if we zoom in, you're still getting a lot of it, but they're modeling it more for that purpose. And I just bring that up because Design X, we get really caught up in modeling every little detail, because Design X originally focused a lot on that. With smaller scanners, usually you're scanning one object and you're trying to make another one, and you're trying to, with the most accuracy, reproduce that object. But with this, it's kind of a mind shift. It's a different kind of deliverable that you're giving. So you see here, now we got the majority of that robot and even its add-on fixtures and stuff, its tooling that it's got on there added to it. And then we'll jump forward here. So they went ahead and took that and modeled that as well over here, because there was enough different about that. Oh yeah, it's a different model altogether, and it's got different fixturing on the floor, so you can see that it's all significantly different. And we'll just scroll down, and you'll see they're going to model a lot more of that in the beginning of the next one. And again, even this one is a lot different than the base here or there. So that's the purpose. I think the majority of that is to understand where all that is and how they connect together. So really neat application. Yes, it's simple to model. A lot of this stuff is very basic modeling, so that's why I'm focusing on more of the application here in this instance of what they did, not as much how they did it, because the how is a lot of extrusions and just moving objects around, basic cutting, adding and removing squares everywhere here. But it's a phenomenal use case for 3D scanning and Design X to be able to document and create these cells.